Hello, pre-algebra class. Welcome to another episode of Mr. Chow Time. Today we're talking about complex fractions and unit rates. This is lesson 3, page 194, if you're following along in the book. Complex fractions. What's a complex fraction? It's a fraction with fractions in it. So, for example, 1/2 over 3/4. This is a complex fraction, right? So, we've learned about several different types of fractions now. Basically, a regular old fraction would be like 2/3, right? And then we've learned about mixed numbers, which is a integer in front of the fraction. We've learned about improper fractions, which is where the top is bigger than the bottom. And now we're learning about complex fractions. Yippee. So, how do we simplify complex fractions? Remember that the fraction symbol, this is a really nice looking arrow here. The arrow is pointing at this fraction sign, and a fraction sign is another way to write a division symbol, right? So this is the same thing as 1/3 divided by 1/2. And also remember that what's on top of the division and what's on the bottom of the division is basically in parentheses. And so in this case, it doesn't really matter that, because 1/3 is already it's already a number, right? Even though 1/3 is basically 1 divided by 3, 1/3 is still a rational number, and so this is still just a number. We can just leave it like that. We don't have to do anything to it. But if it had some other operations, we would have to do something to that first. But it doesn't. It doesn't have any other operations. It's just a number. We can leave it like that. 1/3 divided by 1/2, dividing by a fraction, is the same thing as multiplying by its reciprocal. So this is 2/3. Your turn. Let's do the first one. 1/3 divided by 1/4 is the same thing as 1/3 times 4/1, which is 4/3. I would take 4/3. I would also take 1 and 1/3. Either one is fine with me. I don't mind improper fractions myself. Some teachers don't accept it. I would accept an improper fraction. I would also accept a mixed number. All right, your turn number 2. So 1/5 divided by 6/7 is 1/5 times 7/6. That's 7/30. We cannot simplify that. So that's it. 4/3, 7/30. Now let's take a look at an example where we have just a fraction at the top. So this is 1/4 divided by 2, right? And 2 is the same thing as 2/1. So this is the same thing as 1/4 divided by 2/1, which is the same thing as 1/4 times 1/2, which is the same thing as 1/8. Your turn. The first one here, 1/4 divided by 2/1 is the same thing as 1/4. It's the same thing as the previous one, huh? Okay, let's ignore that one. This one we just did already. Okay, let's just do this one. 14/7 divided by 9/1, which is 14/7 times 1/9, which is 14 over, what is that, 63? Does this have a dilly-dally? No, I don't think so. I think this is in lowest terms already. All right. This is real life. Jeremy, good old Jeremy. He can walk 1 1/3 kilometers in a quarter hours because he's super fast. Find his average speed in kilometers per hour. So, 1 1/3 kilometers in every 1/4 hour. Why are we dividing here? That is a good question, huh? Okay, let me see if I can describe this. So when you're dividing by number, for example, if you have 15 pieces of candy and you're going to divide it into 5 groups, then each group gets 3 pieces of candy, right? So this is candies and this is people. Okay, so like let's say there's 5 people. Then each person, this is a total number of candy. This is the number of groups that we're dividing it into. And then this is the number that each group gets from the total. Right? So from the candy, each group gets 3. Does that make sense? And that's when we're dividing by just integers, right? Numbers that are bigger than 1. But when we're dividing by a number smaller than 1, we're not actually doing that anymore, right? So if I took, for example, 15, and I divided by 1/2, I'm no longer taking candy and dividing it into like half people, right? It's not like, oh, here's a half a person, the other half a person, who knows, but that's not what's going on here. When you're dividing by a number that's smaller than 1, what you're doing is you're finding out we're splitting the total things into this fraction. So instead of a half a person, what we're really talking about now is half candies. If we have a half a candy, how many groups of half candies do we have? And we have 30. We have 30 groups of half candies. So we're not actually asking how much distance we're splitting up into hours. We're finding out in every quarter hour, in every 15 minutes of time, this is a clock, and this is 15 minutes of that clock. He's traveling this far. What if we were to, like, how many groups of this thing are there in a whole hour? I hope that makes sense. If not, you probably need to come talk to me, because this is going to be a portion of what's going on in this this unit is understanding when it is that we need to divide by fractions. Because remember, the questions aren't going to come to you looking like this, right, on the test. There will be some. Those are the 1 point, 2 point questions. The questions that actually, like, you know, mean something on the test, those are going to be most often word problems like this one. And you need to know what operation to use in the situation. So anyway, let's get into it. 1 1/3. So I'm going to convert this number actually into a improper fraction, because I like it more like that. So this is going to be 4/3 over 1/4, which is the same thing as 4/3 divided by 1/4, which is 4/3, times 4/1, which is 16/3. So are we done now? 16/3 kilometers? I suppose so. But I said that I would allow you to write numbers as improper fractions, but only if it makes sense in the context of the question. The question is asking for an average speed, and you would never talk about a speed like this. You would never say 16/3 kilometers every hour. So you should convert this, and this is going to be 5 1/3 kilometers per hour. Okay. I bet there's your turn coming up. Daniel can ride his bike 4.5 miles in 1.5 hours. Find his average speed in miles per hour. Okay, so another way that you can figure out that you are dividing here is in the question, miles per hour. This tells you that the answer is going to be in miles per hour. So, what do you do here? Welcome back. Well, I've already kind of done part of the problem for you. You just put 4.5 up here because it's in miles, and then you put hours in the bottom, right? Miles per hour, and then you divide. So 4.5 is the same thing as 9 over 2 over 3 over 2, which is the same thing as 9 over 2. What am I doing here? Divided by 3 over 2, which is 9 over 2 times 2 over 3. Then we can reduce this. That's 3. 3 miles per hour. Okay. Writing percents as fractions, a percent. Hopefully everyone remembers that 100% is equal to 1, right? And 90% is equal to 0.9, and so on and so forth. So 100% is basically when you're writing percent, you take whatever number you have, and you, for example, 1, which is 1.0, and you move the decimal over 2 times. And that gives you the percent. So if you're dealing with 0.85, you would move this over 2 times, and that's 5%. So if you're writing 33.33% as a fraction in simplest form, you would have 33. Well, first I guess we have to convert the 1/3 into decimals, right? 0.33. Oh no, we're going to a fraction. Sorry. 33.33% as a fraction. We would move the decimal point, which is over here, over 2 times, right? Which is 0.33 and 1/3. But 1/3 is 3.33 anyway, repeating. So this is basically just 0.3 repeating. And then to write this as a fraction is just 1/3. Should I talk about this again? Yeah, I'm going to talk about this again. So in case you've forgotten or don't remember or did not learn the first time how to convert a repeating fraction or decimal into a fraction, 0.3, and I'm sorry if you did learn this the first time, we're going to set that equal to a variable like x. And then we want to get this into a integer value, right? Because a fraction has to be written as an integer on both bottom and top. So we want to get rid of this decimal. And one way that we can do that is by moving the decimal over, which is multiplying it by 10, which means we have to multiply this side by 10. Multiplying x by 10 is 10x. And on this side, we have 3.3 repeating. Now we can just subtract 0.3 repeating from both sides, which is x, right? Because 0.3 is equal to x. And that leaves you with 3 equals 9x. Then you just divide both sides by 9 to get rid of that 9. And then you have 3 over 9 equals x. Then you simplify this. You can divide both the top and the bottom by 3, and you get 1 over 3 equals x. So that's how you do that. If you did not know how to do this, the first thing that I would have done is to to convert this into the decimal. And then you can do this step. Some of you, though, already just knew the answer. But that's not the point, is it? Because you're not always going to know the answer. All right, your turn. Write these percents as a fraction. Welcome back. 4.5% is 4.5%. Move this decimal over 2 times. So that is 0.045. That's a 4, not a 9. And then to turn that into a fraction, there's 1, 2, 3 spaces. So we put that over 3 zeros and a 45. Then we have to reduce this. We can divide both the top and the bottom by 5. So that would be 9 over 200, right? And that's probably the simplest form right there. Yeah. And then 3 1/3%. And remember, 3 1/3, a third is just 0.3 repeating. So this is 0.3 repeating. And so again, we have to do that same kind of arithmetic, right? So in order to get this past the 3 past the decimal, we'd have to multiply it by 100. And so that would give us 3.3 repeating equals 100x. And then, and then subtract x on both sides, which is 0.03 repeating. We need to move this over even one more, don't we? So this is going to be 3.3 equals 99x. Right? So yeah. Am I doing this right? Yeah, I am. Okay. So then we have to multiply both sides by 10 again. So this will be 33 equals 990x. Divide both sides by 990. And that gives us 33 over 990 equals x. And then divide both the top and the bottom by 33. And that gives you 1 over 110. Is that right? I'm doubting myself here. 990 divided by 33? Oh, it's 30. 30. What's wrong with me? Over 30 equals x. 1 over 30. All right. Good night. Or goodbye if you're in class.